All right, guys, we're going to get started on the advanced visualization practice handout. This was posted a little while ago, but I thought it would be good to have a video for you guys to reference when you're doing your plots in the future, in case you're still confused about aesthetics versus mappings and all the different things that you can do within a plot. So we're going to jump right into it. Some guidelines, you can pause the video and read them right here, but we're going to assume that you have read them. So we're just going to do question 1 right away. So question 1's asking to use the Gapminder dataset in the Gapminder library to recreate a version of that Hans Rosling's famous data visualization. If you recall, this visualization was essentially like a animated movie where each plot was showing a different year, and it was graphing life expectancy versus the GDP per capita. So since it's a single plot, we're going to be doing only a year. So if we're thinking about this chronologically, we know that we have to first cut out all the data where the year does not equal the one that we want. There's no like certain select function that we can do for this. I think the easiest way to go about it is to use filter, because as this again, filter is like deleting observations that don't meet the criteria we set. Also, sorry, there's someone outside deciding to do some chainsawing. I can't really tell, but if you can hear that, I apologize. I'm just gonna try to talk a little bit louder. All right, so as always, we're gonna start off by doing our libraries. So library, tidyverse. Library stat 20 data, library Gapminder, and now we're going to pull the data of Gapminder. So if you're a little confused about data versus library, I like to think about it as libraries being, the libraries that we have here on campus. They all have different characteristics that make them unique. So for instance, Moffett is a talking library, Doe is quiet, and Southeast Asian is for Southeast Asian studies. The data are like the books that you can pull, or the characteristics that you can pull from these libraries. So within stat 20 data, or yeah, let's use penguins for instance. Within the library of stat 20 data, let's say it's Moffett, I will go in and I will pull out a book about penguins, and that has all the data that I need. So just a little aside for you guys in case that is still tripping you up, because I know when things are named the same, it can get a little confusing. But moving forward, we're just going to run that really quickly. I have it already run down here when I was troubleshooting everything, so it won't show up with the real red message. If you do get that red message, it's fine. It's just telling you that it's been run. But we're going to start off and do Gapminder, a pipe. And then this question is asking us to see, a single year. So I want to know what years there are in this entire data frame. So I'm going to do count year. And then if you run that, we can see all of these years. So I am going to use, let's use 2002. Yeah. So I'm going to start a new pipe, because basically what happens with this count function is that if you try to use like a filter for year 2002, it's only going to give you like this n value, because they've basically replaced Gapminder for this pipe into just a table that has year and n. So we're going to do Gapminder again, just the original data set, and now we're going to want to choose the year. So we already talked about this. We want filter, and we want to make sure that the year is equal to 2002. We want to erase all the observations where year does not equal 2002. So we're going to do year, our variable, has to absolutely equal, and then because 2002 is an observation and not a variable, we're going to put it in quotation marks. So if we run that, we can see that we have all the countries, all the life expectancies, all the continents, and the different, all the years are the same as 2002. So we're going to build on this. We're going to put in our ggplot, and then AES, this is where you're going to put in things that are specific to a variable or a column in a data frame. It's going to assign different levels of, color or shape to a certain characteristic within the variable. So we're going to do aesthetics, but this is also where you do your y equals. So we're going to do y equals GDP per cap. There we go. And like exp. And then, as always, ggplot comes with their geom, and we're going to use point here. So let's see how that is. All right, so we have our point graph, but everything is a black dot. We don't know what is a different continent. We don't know, how is it actually supposed to look like. We don't know if these are all America or if America is somewhere scattered in here. So we're going to go ahead and use some color and shape and size to make things a little bit more visually appealing and understandable. Right. So let's start off by explaining the difference between mapping and setting. So mapping is when we assign one of these properties, shape, color, size, to a column in the data frame. It's also called aesthetics. I call it aesthetics because that is where you put it. You put it in the aesthetics brackets. You don't put it here. You put it right after like your X and Y. So setting, on the other hand, is when you want to adjust the overall look of the data frame. The plot. That doesn't have to do with anything of the data in the data frame. It's just kind of like a blanket statement, which is what I like to call it because it will affect everything. So I'm going to show you how those two different things look like. But first, I'm going to show you this really handy trick called colors. So this is going to show you all of the little tags, I guess, for different colors in R. And there are a lot, but my favorite is steel blue. So what I'm going to do is that I'm going to show you what color equals steel blue looks like when you put it in the setting. So remember, setting, it's going to apply it to everything. It's a blanket statement. And we see that happen right here. Everything is blue. This still doesn't really give us much information. But, at least it looks pretty, right? But we want our graphs to be functional. So now, because we want to do it by continent, we should definitely do it. We should definitely separate the different continents. So to separate these different continents visually, we'd want to use aesthetics or mapping, just because that means everything is being assigned a different level depending on that characteristic. So Africa is going to look different from America. Yeah. So when we're doing aesthetics, we're going to do, let's say we do shape here. So we want to do shape, and usually shape goes along with things like triangle and quotation marks or a number that corresponds to the shape. So 3 is like a cross for some reason, but you can always Google those, or you can just do something like this, triangle, and it will, if I spell triangle correctly, and it will look like that. Oh, sorry. I meant to put this here. I want to just show you how that's supposed to look like. So again, blanket statement, everything is a triangle and there's no differentiation. So if we wanted to instead put shape to differentiate the continents, we're going to do shape equals the variable, and the variable is continent. There you go. So now every continent has a different shape, and you can see all of them just kind of piled up over here, and a legend for all the different shapes. Great. Now we can, I do want to show you what it looks like when you flip these two. So color equals continent, and shape equals, let's say, triangle. Okay, so now the colors are separating each continent, as you can see from the legend right here. And all the shape is a triangle. Okay, awesome. So now that we've gotten our colors to look amazing, and our shapes all look a little fancier than just a circle, we're going to start by doing the labels. So labels are very important for your graphs. Not everyone is going to have a data frame that has, the variables make sense. For instance, life expectancy could just be in the data frame as LE, and nobody knows what LE is besides you who is making the graph. So we're going to add something called labs. So labs is kind of a weird name for this function. Treat it as just like a geom point. It's another way for you to add things into like a chart element. And we're going to start off with our labels for the X and Y axis. So X is going to be equal to, and then you always want to put these in quotation marks because they are like a string of characters. It's a thing that you name. And I'm going to say X is the GDP per capita in 2002. And then for my Y, I want it to say life expectancy in 2002. And just run that, and you can see they change these X and Y axis labels. Perfect. Also, always remember that these labels are matching what your variables are, because it will be very confusing if you had life expectancy as the label for X, but you're actually graphing GDP per capita on X. Now we're going to do really fun things called themes. So up here, I'm going to just run this for data gapminder. It's called library GG themes. And themes just make things so much easier. It makes your backgrounds look cute. It makes your lines look cute if you're doing line graphs. And I'm just going to run that. Okay, I just did some troubleshooting. So to get themes for our studio, you're going to first start to install it. So it's called this line right here, install packages, GG themes, and you're gonna run that after you put in library. Nope, if I spelled library correctly, library GG plot 2. And then you install GG themes, then now you can call up library GG themes. There you go. So for themes, they are also just another aspect, a chart element, but they're not going to go into labs. They're its own thing. So you're going to put a plus, and then you're going to do theme, and then the theme that you want. So I love the clean theme. I think it's very minimalist and straight to the point. And this is how it changes the graph. So it changes all of the font and font sizes. So now for the last guideline, add an annotation that draws a particular feature of the data. So to draw a particular feature of the data, we're going to use the function annotate. So annotate is its own little thing. And so it's going to be another chart element, annotate. And so there's two types of annotates that we've learned. So there's text, where it's just the text that shows up, and then there's segment. So I was running this in the background, so ignore this little line here. I'll show you what it means. So annotate, we're going to put text first. Obviously, we want to tell what's at that little line that's pointing to the point that we want. And we're going to say it's going to be a label that says fancy label here. Obviously, replace this with what you actually noticed in the plot, but for time's sake, I'm just going to put label. And then I want it to show up, okay, ignore the graph because I haven't run this yet, but I want to show it around x equals to 1000 and y equals to 70. So if we run that, that's how it looks like. So there's just going to be a little fancy label here. I noticed that it is a little hard to see because it's right in the middle of things. So maybe I want to drop it down to 65. So y equals to 65. There we go. So now you can see the label. Now, to know what we're pointing to for that label, we're going to add another annotate. Annotate, and then the brackets. So segment is going to be the line that you use. So segment in quotation marks again. And for this one, all you have to do is tell it where the x coordinate is and where you want the end x coordinate to be. So your start and your end of the line. So let's say I want my x coordinate to start at let's say 67 to give it more space. And I want it to end, so x end equals to, like, we can put it at 75. And then we're going to do our y stuff. So y, oh, sorry. I meant that to be yn. So for x, I'm going to say I want it around the same place that I put it. So let's say it's 9,000 instead. So it's going to start at 9,000, but I want it to be vertical. So it's going to also end at 9,000. I'll show you what happens if you don't choose that. Unexpected symbol. Okay. Oh, I think we're just forgetting a comma. Yeah, there you go. See, easy fixes. A little, it sparks some panic, but it's okay. It's just that you forgot a comma, and that's something that you might do as well. So as you can see, it's a vertical line pointing from this 75, 60, 67 to about 75. And if we change our xn to say 10,000 and run that, it's going to be slanted because now your x starts here and your x ends here. So if you just move it up, it's like, you know, how you find a slope and the 2 points that you choose. So yeah, that's how you annotate. And all in all, this looks like exactly what we want. The guidelines, we have plotted the data for a single year. Yep, this is only 2002. We have put GDP per capita on the x-axis and life expectancy on the y. Here you go. We have distinguished the continents, and then we are not using the default. So we've done that. We've made all the shapes triangles just to make it look pretty, and the continents are different colors. And then we have altered the labels. Yep, no longer GDP per cap and life expect. And then we have changed it to a theme. Yep, and added an annotation. Yep. All right. So that is how you do all of the advanced visualization for Stat 20, at least up to the point that we have learned. If you have more questions or want to try new things, feel free to ask the tutors or drop it in the comments. All right. Have a good one, guys, and good luck.